Hello, my name is Marko Kovač. I'm coming from Jozef Stefan Institute, Center for Energy Efficiency. I will be presenting. Where is the? Oh, okay. I will be presenting my small research, improving solar potential map, which is ditching net metering, embracing demand curve and local weather, and maybe I can maybe also help answering on your last question about efficiency and so on. I think Professor Striti, he was quite right. Solar is a bit cheap, so we can play with it. Just the introduction. I am, let's say, back to solar for 2 years, and I'm trying to see what solar can do from us from level up perspective, because of course we have a lot of efforts in last years for renewable energies, and solar is one of the big solutions also in Slovenia. And however, there is also quite a lot of negative about that, because our distributors are a bit unhappy regarding the variety or regarding the influence that solar has on the grid. But I was first trying to calculate self-sufficient homes or microgrids with battery power, battery-supported microgrids. And I realized that net metering is not the best option to have. And the optimal scenario was to catch more solar energy during the winter. Of course, this is not easy to do, but I try with angling the solar panels according to this goal. And in my previous work, I found out that with this, I can do 10 and 15% improvement on reduction of battery size, and 30% of reduction in battery size, and overall cost to reduce it by 15%, something like that. Of course, for this, I need some kind of model. And my model is, I call it my Swiss knife because it's quite universal. Maybe it's not the best one, but okay, I'm just playing with some parameters to see what's going on. And this presentation is based on the meteorological data for Slovenia. We have 23 measuring points, and at each point we have a typical year. Of course, we have this solar map. We know for each point how much solar radiation we get per hour, and we have also the climate zones, temperature, and so on. So the idea is to put this together, and for each house we can calculate for each year the balance. If we put on the battery and have some math, we can optimize the angle, the battery size, the panel size, and so on. And these are some results. They come usually in 2D, 3D, because there are a lot of parameters. In this case, each of these squares, these rainbow squares, shows area of photovoltaic against battery size, and the black line in the middle is the optimal one when we have zero, the minimal, when we have no shortage of electricity during the year. So this was my curve. Not the net metering, but well, we have to have electricity whenever possible. Okay, so you can see that there is quite a difference. We have okay. Sorry to This area is mountain area, for instance. It's quite high in the mountains. Have a lot of snow, actually, and a lot of sun also. However, this area, quite close to it, you can see the quite different. This is the most rainy area in Slovenia, so you have a lot of battery, but not so much sun, and so on and so on. Okay. If I can just show you the middle curves, these are the 23 cities that I have data for now, and this is quite same. We have sorry, still getting used to it. We have this coastal area, and we have this small airport in the mountains. Of course, it costs quite a lot to have self-sufficient building there. I also tried to see if there is some dependence on the size of the cities for which I have data or something like that, but it's not. Of course, the area close to the sea is the best, and from 23 points, there is not a lot. There is not very good map I can do, but I realized that this is something interesting. Maybe, of course, we have this area. I told you it's quite rainy, and this area is quite mountainous, so a lot of sun. Of course, we have our wine areas, which are very suitable for self-sufficient, not just for electricity, also wine. And the middle of Slovenia is not so good. And I'm talking about the costs, about, let's see, 25,000 euros, about to 60,000 euros for installation of one house. So it's interesting number also. Okay, my conclusion is, my aim was improved solar potential map, which would show us how much money we need to invest for self-sufficient housing. I was used proper weather data. Results show some discrepancies regarding climatology characterization. Thank God, if everything will be the same regarding climate, then I would need that. I wouldn't need that simulation. And okay, maybe in the future I would need some geometric properties going in and so on. And for the future work, of course, more data and shading. And regarding the previous question, I showed here that for instance, I need an elevation about 60 to 64 degrees for the solar panels to get the best results. So I am willingly throwing away some energy, some solar energy, just to have some more in the winter. So I'm trying to catch each sunlight in the winter regarding, and I'm discarding everything in the summer. Thank you.
Thank you. Thank you for a nice presentation. Have you considered mapping the underground, I think, of the water flow? Because if you want to make ground source heat pumps to avoid the coldest winter, especially in the mountains, you could use the groundwater as source, but then you need to map the water flow.
No, my colleague is doing that. We're producing the map of... Oh, sorry. Yeah, my colleague is doing that. He's doing map of for geothermal energy map, but not in this area. I am more of surface sun person.
Thank you very much.
Thank you.
Every country should probably start implementing solar and regenerative systems with such wonderful studies. You made an estimate between 25 and 60 kilo euros per, let's say, standard house or home.
A low demanding, yeah.
Yes. My question is, if you considered in this estimation to cover 100% the energy needs with solar energy, or you can also look for an alternative, let's say, to cover only part with solar energy and the peaks with conventional energy. And that could reduce maybe the total investment cost, because I have in my country and with my former students a nice saying. It's not nice to stay in queue with a Rolls Royce of 5 liters in Bucharest, waiting for the green light, you know. It's much better to stay in queue with a small Fiat 500 to wait. Because if you install too much regeneratives, that means you have a lot of sun all the year.
I have a answer to this question. Basically, it's two ways. One way is, of course, you can use solar heat. And we found out that solar heat systems are cheaper than solar electricity. And also our calculations show that, yes, this is the case. We can, with solar heat and solar storage, solar thermal storage, we can produce cheaper house. But unfortunately, this is not my topic. And another one was, what if I introduce grid? If I use grid for instead of battery for maybe 10 or 15%, this also reduces my prices. But I wanted to have this hard case. What if I just go and cut the cord? But in my, I have a science paper, and in this paper, I've already calculated those two possibilities. Thank you.
Thank you very much.
Thank you.